If you still have problem, don't hesitate to say you have a problem. I don't have any issue with repeating the same thing. Are we all there? Dave? Yes, please. Under compliance, right? Yeah, what do you have? Yeah. Okay, so the number 16 is 1. Under compliance, number 16. Yeah, 16 is 1, 17 is 2. 19, 1, 20. So in age, 95 is a case for patient ID 235. 67 under the age, 67 is a case or an observation for an ID number 233. That's what I mean. And then the variables are the ID numbers, age, marriage, BMI, weight, ethnicity. Those stand for the variables. It means that it is not the effect that you are looking at which has caused your values to be significant, but any random chances can occur and give you the same results you obtained in your study. For instance, you say that those who do take alcohol don't succeed in life. And here comes a group of arguments. Now, how do you prove your data are still valid? You said that alcoholics don't succeed, and you've got alcoholics who have what? Succeeded. So if you select a group of alcohol people who did not try in life to make it and they became poor, and that was your argument, then the control should make sure that other people who are probably not alcoholic should also not be poor, or all alcoholics should have that conformity to your hypothesis. So the other control to your hypothesis is people who are not alcoholic. How poor are they? Are there other people who are also not alcoholic too poor as those that you use for your study? If so, then poverty can come by random chances but not your alcoholic status. 2, the extreme people who are also alcoholic and rich should be considered in your study. Let's put that one aside. If we are doing our analysis between, for instance, BMI and weight, you can copy all these 2 data into your Excel and go and calculate your population mean there. We are doing this and you won't go there again, you go straight to the analysis. So I'll copy this and I'll go and paste it in Excel. So here I'll paste it. It will give me a warning. I say, okay, I still want to paste it. Then I'll go on there again. Now, not the BMI, I'll pick the weight now and I'll copy it. And I'll go to Excel and I'll paste it there next to it. Control V. It will give me rubbish and it's paste now. So now, these are the 2 data sets that we are going to use, but it is asking for population mean. It may also ask for standard deviation for the data set. So you will have to conjure your mean and standard deviation, STDV. So our mean, those of you who are in the basics of Excel, you know this already, is equal to average. And I'll select the average and I'll copy these ones. Don't bother because you don't need to open yourself. Or if you are quicker, you can do it. And I'll enter that. That's my mean for the first set. And then the standard deviation for the first set, I'll do equal to STD. And this is a sample, not a population. So, and I'll go and select my participants down here. And I'll close the parenthesis and I'll do enter and it calculates the standard deviation. Yeah, I want to interpolate them, so I'll select both, go to the plus down here, and I'll draw them further and it will calculate the rest of them for me. Now I know my mean, I know my standard deviation. So if this SPSS is asking me for further data, I know the mean for group 1, and when you select the edit, now you can decide to bring the percentages on here. There is a blue icon with a plus. Inside here it says data label mode. When you click on that data label mode, and you click on every slice, it adds how many participants are there, and on and on. So that's how you should do. You should take pairs away if one of the parameter is omitted. Does it make sense? Then we continue with that. So when you say okay, then it computes a Poisson correlation and it asks you if it is highly positive. Inside the box it says none, and then if it is positive, it tells you body mass index and measure body weight was positive. No linear correlation, none of them was that, and none of them was negative or highly negative. So in terms of their correlation, there was a positive correlation between that. And if you look at the above correlation parameters it brought here, it gave you between body mass index and measured body weight. It gave you a measured body weight Poisson correlation here. The significant as in two-tailed, and the two-tailed value that you got here was less than 0.01 compared to an alpha of 0.05. It is quite significant, and it's given a note at the latter part on there. So if you look at the measured body weight Poisson correlation, it gave 0.788 and it put the asterisk 3 as to how far significant it is. If it is 1 asterisk, it is slightly significant. 2 asterisk is moderately significant. 3 asterisk, it is standard significant. 4, it is highly and highly. It goes up like that. Because it is saying there is a good correlation between them, the next thing you can see is to visualize it. Unfortunately, SPSS does not compute a graph for the correlation that you do. That's the unfortunate thing. So what you have to do is to plot a scatter plot and insert a line of best fit and see if the two parameters that this analysis is saying is significant. It really shows graphically on the graph. So go back to your analysis, your data set, and it is you did between weight and BMI, and the same thing you're going to do there. You go to analyze, you go to graph, and you go to scatter plot, which is the last but one. You click on the scatter plot and you say you want a simple scatter, and you say define your parameters, which means body mass index and measured body weight. You have them already under the X and Y axis, and you say use the chart spectrum. You say okay. Now when you say okay, it draws a scatter graph for you to see how measured body weight. So in order to make this graph meaningful, you do your right click, you go to edit, and on the edit you right click again and you say you don't want to see these grid lines. Go and click remove grid lines, show the hide grid lines. I don't want the grid lines, I want it to be plain like this. And you input your line of best fit. Remember, on the options up here there are two that has a line of best fit. They are not the same things. One of them, when you put the cursor on, it says add a reference line from equation. If that is a regression line you are putting in there, and it's not going to be the line of best fit. When you draw that, it will go direct to the 0 point. So it will draw the straight line to the 0 point. Let me put in that, and it has drawn it directly to the 0 point. So the formula is going to compute here is a regression line computing based on the line that crosses the 0 mark. I don't want that, so I'll just click on it, and I just want to delete, or I'll do undo, and it takes it away. But I want a line of best fit based on the data I've entered. So it is not this add a reference line from equation, but you will go to this, which is add fit line at total, and then it will draw the line not considering the 0 point, but based on the 95% of the data that you have. And you close this one, and you see that a line has been drawn, and it has though computed a formula, but that formula is based on the fitness of these two, the data, the scatter plot. When you go to the data label mode, you click on that, and now it brings up a plus sign and a rough door. Any data plot that you click on it shows you which of the patients you have plotted here. It's either patient number 20, patient number 6, patient number 4. Are you following? You should be able to follow what I'm doing, and you should be glad doing it, as I'm glad doing it. So it will tell you the patient, the means between the two. But this is not a good one. I'm just trying to make an analogy for you to understand it. So let me remove this from the variable, the interview identification from the variable. And I put something like, let me say visceral adiposity index under the variable. So that is what is going to be summed. And then the marriage status is what is going to be used for the pie chart. If I say okay, it means that under the marriage section, and it has computed the visceral adiposity index for the values. It has put all of them together for people who were not married, and it's the pink and that. If you want to show them up here, you do a right click, you do edit, and you say, you click on this data label mode. When you click on that, when you click here, it has computed all of them together, and it was 31. All of them together, and it was 4. Here, all of them together, and it is 5. So if you go to the visceral adiposity index and you check all those who were married, and you put all their visceral adiposity index together, you see it will sum up to 31. So it depends on how relevant it is going to appear on here. If you go on here and you go on the graph and you click on the pie chart, now what you're going to do is to select from here either number of cases or summary of variables. If you say summary of variables and you select this here, what you are going to do is you can select a row and a column as well. This is the last thing we are doing and we close. You can select a row and a column as well. So for instance, I want my row to be, for instance, the age. Okay, so this is what I'm going to do. Now I don't want the visceral adiposity index, I just want the age. So I will remove this and I'll sum all the age. I'll just remove this. I'll remove this from here. I'll sum all the age together. I want the age for each of the groups. So I'll select the age as the variable to be computed. So that is the age that will be summed up. And I want the graph to appear as marriage. And I want other parameters to be considered as well. So I want to see, let me say religion. And I also want to see gender, all on the same pie chart. So one will be in the column and the other will be on this. So I will remove this. So I want religion and gender here. So gender, what is your gender? And I'll bring that one here. So I've got religion and gender in the row and column, and I'm going to make the pie chart in a form of marriage status, and then the values to be computed together to sum up is their age. But this is the graph that it has drawn for me down here. So it has computed 4 different things together for me. One, what it has summed up inside each of the box is their age, the total age. And the total age it has summed up here, it made sure that it also described them under religion and also gender. So under gender we have male and female, and under religion we have Christianity and Islam. So, and the colors in here represent their marital status. If you want to compute the values in here, you can right click, edit, go to this sign, say data label, and you'll be clicking on each section to see how it will compute these stuffs together for you. So it means that if you go to the Christianity, these were the females here and these were the males, and then the males here also gives you this idea that 581. So if you compare this side, the married, which is 581, to the divorce for the females here the total age was 581 and here is 128, and you see that the difference. So more of the males were married whilst much of the females were divorced. So you interpret according to how it appears on here.